Welcome to the series of videos on electromagnetism. So in this series of videos, we are going to see the relationship between electricity and magnetism. But before we start, let's first define magnetic field. So here's a small compass, and in this you have two ends. One is a head and the other is a tail, and you see the head pointed here and the tail pointed here. So let's draw this. Let's draw this. So you have the head and your tail, and this is your north of the magnet, and this is your south of the magnet. So the reason why the north is pointed here is because the Earth's magnetic south is here, and the Earth's magnetic north is here, right? So the north attracts the south, and here the north is attracted towards the south. So in general, at this point, we say the Earth's magnetic field direction is like this. So we represent this as B, and we call this as a magnetic field lines, right? Now, Oersted found out that there is a relationship between the magnetic field and the current. So if you have a current passing in a conductor, then there will be a magnetic field. So let's do a small experiment to find that out. So here is your setup. So this is your line of conductor where we have the current pass through. So we switch on, and there you see the current is passing through this conductor. And as the current is passing through this conductor, I move this compass. So as you can see, the compass is rotating around this wire. So the compass is rotating around the wire. So the direction of the magnetic field, if I were to trace the path of this needle, it's moving in circles, as you can see, right? And if we can reverse the direction of the current, and the way I do that is by unplugging this and reversing the direction of the current, then I would see that the magnetic needle changes the direction. So earlier was anti-clockwise, and now you see is a clockwise direction. So earlier the needle was going in the other direction, and so here you see that it's clockwise, and we can remove and change the direction. There you go. You can change the direction, and you see that now it's anti-clockwise. So changing the direction of the current, in fact, makes it clockwise or anti-clockwise. So the best way to go about interpreting this is, if you have the current which is passing through here in this direction, then your magnetic field lines will be like this. So that's basically you're tracing your compass path, and if your current moves down like that, then your magnetic field line would go in this direction, right? So this is your anti-clockwise direction, and this is your clockwise direction for this direction of current. And the way to think about this is that you can think of your hand holding the wire, and this is your thumb, and if this is your B, the folding fingers is B, then your thumb is the I, and here it's exactly the opposite. So here you have the hand like this. So the B is folding in the direction of the current. B is folding such that your thumb shows the current, then your folded fingers actually show the direction of B. So that's how you can find with your hand, and make sure this is your right hand, and that's extremely important. If you do it with the left hand, you will see that this is also right hand, right? So thus you establish that current carrying conductor produces a magnetic field. I missed showing you the fact that this needle won't be moving when there is no current. So you can see that this needle is not moving when there is no current. So you can be sure that it's a magnetic field produced by current that moved this needle, right? So I'll see you in the next video. Until then, ciao, bye.